CEO, Mr. Ilmari Kontulainen. Kontulainen, I was incorrect. Welcome on stage with a round of applause. Welcome.
All right, thank you. Mic's working. Do I get the picture?
Sure. Just press the, I'm sorry, that magic button.
Right. So, hello everybody. My name is Ilmari Kontulainen, and today I'm going to talk about Dockerizing the IT infrastructure. And well, actually, Docker is only one part of our journey to modernizing our infrastructure and how we deliver our software to our customers. So in DevOps, like everything else, the tools are just the ways to accomplish something. But the important part is the journey forward and the continuous improvement. And I'm actually going to go a bit to the details, so it's not going to be this kind of like high level description of what Docker is or what are the benefits, but I'm going to actually tell like two stories from our experiences of how we were able to cut down our release times from 90 minutes to 9 minutes, so 10 times of improvement there. And we were able to also cut down all the problems during customer installations, but not all the problems, but still some of the problems. And then on the other hand, I'm going to tell how we have been able to improve our internal IT, where taking new service, internal IT service, into use, we have been able to cut down the time from weeks to a couple of hours. But a little bit of background. So my personal background is quite technical. So even though I only have like 10 years in IT industry, which I guess many of you can beat, I've been working in IT support, in software development, in software consultancy, and nowadays more in the business side. So talking to customers, finding out what are their problems, and then delivering solutions through our company, Deveo. And what I like to do in my spare time, I like coaching a lot. So I'm part of Agile Finland. Agile Finland is a organization that revolves around everything Agile, and one part of that is coaching, Agile coaching. You should check it out. And then other kind of self-improvements, as well as doing sports, so basically running marathons and half marathons. But that's about it from my personal background, and then I would like to tell also a little bit about Deveo, so that you could get or understand the context of why these improvements were significant, and basically what they are all about. So Deveo as a company is aiming to improve and enhance the daily lives of both the IT organizations as well as the development organizations. And we currently have solutions for self-service oriented solutions for delivering all the necessary tools for software developers. And so basically, what you can do with Deveo, you can manage code repositories. So we support not just Git, that is nowadays famous, but also Mercurial as a subversion. You can conduct code reviews in both Git and Mercurial. Unfortunately, the branching model of subversion, now we go into technical details, is quite not that good. So we don't support doing code reviews there yet, at least with the same ways as in Git and Mercurial. You can handle access management in Deveo. You can basically manage the access to the tools Deveo provides, but nowadays also for external tools. So if you have an IT organization that's using not just one tool, but a set of tools, you can manage all of the access rights in one place, and even delegate the access management from the IT organization to the development organization to the project teams. You can do issue tracking, and what's best is that you can do everything from that one same platform with self-service approach. So those two are kind of like our key differentiators. But then a little bit about history, so we get into the context. Sorry if that was too advertising type of speech, but we have developed Deveo as a separate product for 4 years. But our history goes 10 years back, where we have implemented similar solutions to some of the biggest organizations in the world as proprietary solutions. And so you could actually say that Deveo is a version 3 of some of the solutions that we have implemented before. Right. But so the product itself is 4 years old currently, and within those 4 years, so I know that there are lots of products with even tens of years of lifespan, etc. But even in that 4 years, we have accumulated quite a lot of different technologies due to what kind of functionalities we offer and due to some design decisions. But to name a few, we use Nginx, Unicorn, Puma, Apache, Redis, MongoDB, Jitsa, Persian, Mercurial, Ruby on Rails, Enter, Go. Probably there are others, but so basically all of that creates a certain kind of complexity. Yeah. Okay. Since nowadays more and more applications are run in the cloud, so you can run also Deveo in the cloud. So we offer Deveo in 2 deployment options. So one of them is a multi-tenant cloud environment where you can have your organizations code and everything in secure place. But some of our customers also want to keep it even more secure, so having the software on their own premises. So installing the software, their servers, behind their firewalls, so that their assets are even more secure. And we support 4 different operating systems there, and we have 3 different deployment options for Deveo. So just to mention, you're able to deploy Deveo as a Convoy server installation, which means that everything is run in one server. And that's, for example, if you're testing out the video or you have a small organization, let's say 10 people, you probably don't need the same sort of scalability and high availability that for example, an organization with, let's say, 10,000 users, 10,000 software developers needs. So there are 3 types of deployments. So one of them is the combo setup where everything relies on the same server. The other one is the high availability setup where you have a separate server for the database, separate server for the web front end, and that's quite deep. And then you have the clustered setup where you actually have multiple application nodes, one database server, and the application nodes share the same storage. But this is just to get the idea of what kind of complexity we are talking about. All right. And if you go to the actual first story I'm going to tell about, it relies or revolves around our deployment pipeline. So basically, like I mentioned, we offer a solution both in cloud but also in on-premise installations. And in on-premise installations, installing, configuring, taking the software into use should be as smooth as possible in order to keep the customer satisfied. And so if we go back again, so types of deployment, we have the combo setup, the high availability setup, and the cluster setup. Then we have 4 different operating systems we support, and for some of these operating systems, we also support like 2 different versions, or even 3. But the numbers can vary. But basically, this comes up to 18 different 18 different installation options you can actually choose from. And how we did it in the past, for customers, it took 90 minutes, and same as us internally, to install Deveo. And well, depending on software, 90 minutes might be small time, but for us, and with the current days needs for very fast time to market and taking services into use, 90 minutes is too much. And how we used to do it, we were compiling basically everything, every service that we needed using Chef automation tools. And we had automation, so we could build everything automatically, and customers could install video automatically. And that worked quite well, but time wasn't that good. And even with our internal deployments and testing everything from clean state took too much. But the time is maybe not even the most important factor here, but more important, it was very error prone that we had just custom scripts running in our customers' environments, custom Chef scripts. And which basically made us need to organize debugging sessions with the customers, and also it left us with some unsatisfied customers. Because if you think about it, that when you are trying out a new product, you want to try it out as fast as possible. And if the product is not such, you can just click and start using it, like in the cloud era and the software service era, you want to install it. But what happens if you start installing it and then you get some mundane error message? But let me tell you, just jump into and try the next possible software that does basically the same thing, or here it is. But so, this was the problem. So for some customers, we received the feedback that okay, we weren't able to install your software, so we started to use another software, or we stopped kind of testing your software. And for some, we didn't even receive any feedback, but we just saw that okay, so you have requested a trial version of our software, but you never came back with anything, and that's kind of bad. And because of the time it took to release new versions, we were actually avoiding these on-premise releases. And we all know what means when we release large batches and not that often compared to releasing small batches often. So, all right. And how did we solve this then? We used tool called Omnibus. Does anyone here use it, know about it? Raise your hand. Okay, 1, 2, maybe 3. Okay, what about FP app, FP Package Manager? Okay, same too. But anyway, the idea of Omnibus is that we are able to easily create full stack installers for your project across a variety of platforms. So meaning that we input some information and our project and all its dependencies, and what it outputs is operating system packages. So for those 4 operating systems and different versions of those operating systems, we get the native installer packages, which are much more easier for customers to actually install in comparison to that thing that they need to run a script, and if it fails or brings an error message, start debugging. Okay. So the Omnibus consists of 5 different components. So there is the typical project scaffolder, and a little bit about the history of Omnibus. So people probably know this configure management tool called Chef. So I presume people, at least some people use that. And basically, the Omnibus is the way how Chef releases their software to not in operating system packages. But it's fully open source, so it's used by us and other companies alike. And basically it consists of five components. So there's the project scaffolder that you can just, basic tools to create your projects and such templates for those. There are the dependency recipes, where you describe what components you want to actually use when you create the installer packages, and what are their dependencies. So you can give the hierarchy and the linkage between the dependencies in your software, and then basically you use Omnibus to create the operating system packages. And then there's the project configurations. So for example, for us, since we had 3 different deployment options, so that means that we have 3 different project configurations. So we have one for the Convoy installer, and then we have one for the database server installation, and one for the web application server installation. So you configure those in the project configurations, and there you set the dependencies which you use to build those packages. Then there's the virtual machine system, where the actual building happens, and where also testing of the system happens. And then there's the project builder, which basically orchestrates all the things and outputs you the results. And one of the benefits of this Omnibus is the catching behavior. And this catching behavior basically means that when you are building your packages like multiple times, and when there is only no changes or only only one of your components or software dependencies change, you don't actually need to rebuild everything like we needed to do before. But you only rebuild those packages that have changed for given project configurations, and the rest of them are in the patch. And the catching is based on JIT and snapshots, and also can be shared between if you do builds for multiple slave instances or whatnot. We used it very basically, so we didn't need all of the functionalities, but the catching anyway allowed us to build package faster. Alright, and so why we didn't use then virtual machines, but why we used Docker instead to build these packages? So, well, it's the, I guess, quite basic reasons. So creating and destroying the virtual machines takes time. Takes much more time than building the Docker images. We needed basically at least clean state for the machines in order for each build. We needed to manage the build tools in the images with more flexibility, and cleaning up the virtual machines after the build was just too error prone as we had bad experiences from the installations previously. And basically, how we transition ourselves from using only the Jeff recipes and basic configuration automation to actually deploying and delivering the operating system packages was that, well, we first listed the operating systems we want to support, and then different software components that we actually need to do. Then we had to create some dependency recipes for missing components, because the Jeff's Omnibus only, because they are delivering the Omnibus just for their internal use mainly, and so they only maintain those packages and dependencies that they use for their delivery. But since it's open source software, anyone can extend and build on top of that. You can build your own dependency recipes. So that's what we did. We needed to build quite a lot of them, but in the end it worked quite well. We used this tool called Kitchen CI that's basically used in the Omnibus to set up the deals and testing. And we first did it with the only the simple set of one operating system and the combo setup. But after we got that working, we extended the support for the separate database and web packages. After that, we added additional operating system and solved the problems in that way. So the iteration is there also the key. Don't take too large chunks of work when you are trying out new ways of delivering your software. Because this was also for us something new, even though since we had used Jeff earlier, basically using Omnibus wasn't that big of a transition, but it's still, whenever there's something new, take small steps and learn from those steps. And how the pipeline then works in practice is that, well, we build the packages, utilize the catching there. Then we create cloud instances, and these are still virtual machines. We deploy the operating system packages to the cloud instances and test the installation of the packages in native environments, so that we get the final feedback. Does the installation actually work? And what were the benefits and what were the findings? So before, building a package took 90 minutes. Now it took 9 minutes. So 10 times faster than the release time. The same goes for the customer installations. So before, they needed to spend that 90 minutes installing Deveo. I mean, for us, it wouldn't be that bad, probably, if we do it once a month, for example. But for customers testing Deveo out, it's probably quite painful. So now 9 minutes is quite okay. Probably it could be faster. But the more important things probably are that there were less problems during the installations and upgrades, since we were able to deliver those operating system packages that work with the same package managers what you use to install any other software. And of course, an internal benefit, we were avoiding releases and not collecting this kind of big chunks of stuff to be released. So that's the kind of main benefits here. And what we learned about using Docker and so on, well, the SSD speed up the Docker quite a bit, and we could also probably in the future Dockerize even our test environments to get some marginal speed improvements. But yeah, that was the first story I wanted to tell you about. And the next one is separately managed internal services. And basically, the problem is we have this thing called Office server. So our team is quite small, and so 10 people about. So we have basically this kind of Office server that we pile up different services where we run it. So for example, we run Jenkins there, we run different packaging scripts, we have some integration tools between different tools that we use. We have some custom CRM there, some databases they use, various tools and services that we simply need to keep our internal IT and different type of services running. And typically, this kind of server, because it has multiple purposes, is the largest technical debt for the organization from the IT point of view. And lots of such server is quite critical, because most of the things, let's say we have our CRM running there, and we have our integrations between some of our tools running there. So if something happens to that server, we basically lose all the interconnections between the tools we use. Of course, we can bring them back with one way or another, but that takes typically time. And another problem there with using this kind of Office server that hosts everything in one namespace, so to say, is that when we want to take some new services into account. So for example, with Deveo, we integrate to myriads of different services and tools. And we of course want to test them ourselves before we say, okay, hey, we support these and these tools and these integrations. So we install quite often some new services, and we want to run them some period of time. And typically, adding these services with this model takes quite a lot of time. And then there are, of course, constraints with the data safety and backups, because typically when you have this kind of messy server, you don't have time to maintain backups or the data safety and these kind of things. So they're just forgotten or don't have time to do it. And so our solution here is Docker. So we Dockerized all the services basically we want to. It's running on their own containers. So the benefits there are that each of the services get their own namespace and storage. And in addition, we are able to link the applications together. So as an example, our CRM system needs a database to run, but we want to run both the services, the CRM and the database in isolation. So we can build and describe dependencies there that, okay, before we can start our CRM or have it running, it needs also a running database to be available there. So these kind of things. And nowadays, since Docker has native volume and networking support, a lot of cool stuff has happened in that front. One of them is this Convoy for backups and recovery, and this is something we took into use, and actually saved us from quite a lot of trouble. So what Convoy does, it creates like thin provision volumes for to be used in Docker containers. It can take a snapshot of those volumes. So thin provision volume means basically that you have a shared storage and you take a slice of that storage and allocate it dynamically per use. And basically so you can have multiple services consuming the same data storage, but they are isolated and allocated dynamically. But basically what you can do with Convoy is you can take the snapshot of those volumes and you can incrementally back up those snapshots to, for example, S3 or any other object stores. And what it allows then, it allows basically the separation of the host or of the application and of the storage it uses. And it also allows that you can restore the volumes to any other host. So you can, for example, do migrations from one server to another with like a couple of commands. And here, how we implemented the transition. We basically listed the components and what data do they store, what dependencies they have, and for each component, just created a Docker compose file, listed the ports and volumes, the mount points, and then created the image that holds the application. And results from this were basically that we were able to, or we are able to deploy new services within hours instead of days. And then for this kind of data security and fault tolerance, we actually had a problem quite right after we implemented this Convoy and Docker-based services, that our virtual private server that's hosted in somewhere Germany, and that was hosting all of this infrastructure, it got the disk got corrupted. But since we had the incremental backups stored, we were able to recover from that incident in hours, because we had the Docker containers for each of the applications, so we could restore those, and we had the storage snapshots. Okay, so there were of course some data that was missing because the backups are taken daily or something, but still we were able to recover in hours from this kind of accident. And with the old approach, where everything would have been just in one place, it would have been basically reinstalling everything by hand or by scratch. So that was very good for us. But yeah, that was the second story I wanted to share to you. And so in conclusion, what Docker and the whole process or change process towards more DevOps kind of way is that we have been able to serve faster installations, less problems with the installations, which is more important. And that has bring more satisfied customers. We are no longer avoiding releases. and we are able to deploy faster production level IT services, internal IT services, and we have more fault tolerance and the ability to recover from disasters faster. So that was my story. I wanted to share. And any questions?
Go ahead.
Go ahead.
Oh, thanks. I just wondered why you choose chef as a document tool and not like some other concept.
Yes, so there is a question of why we choose chef. But there are probably the most prominent reason is that our application, our backend uses Ruby on Rails as technology, and there, since Chef is also like Ruby-based, the configuration management, so we choose Chef originally because of that, and then because Omnibus is part of Chef, and therefore it was easier to choose that. So what I have heard is that Ansible is quite good as well, and maybe if we could choose again, I don't know, maybe the choice would be different, but because we have built so much underlying infrastructure based on Chef already, so there's of course the cost of change there.
It was last week, or I was installing this, so why don't have yet on-premises installation on Docker? So when it's coming up?
We have plans supporting also like on-premise installation with Docker. That was actually the one point that I mentioned in the installation part in the first story. It's coming up in the roadmap and probably within this year.
Yes, I'll ask where you're able to change your infrastructure to be container-based. So how long did it took you?
The IT infrastructure.
Yeah.
Well, of course, we didn't have that many services. We are talking about 20, small services, and so on. But I would say for one person who's doing operations and that sort of stuff, I would say 1 man-month-ish. But of course that time also went to other tasks as well, so it's very hard to estimate the exact amount of time you need to spend on it. But of course it depends on the amount of services and the complexity of the services.
How did you Dockerize your network configurations and firewalls, or did you?
Nowadays, like I mentioned, actually, I have to admit my information is a bit limited in that regard, but nowadays Docker supports is like native network configuration. So I would presume we use this Docker Compose or something to configure also. But yeah. So what I was mentioning, at least we did the configurations for different ports that different services use and so on. So yeah. So nowadays it should be possible. I remember that at some point, like both the native storage and also the networking were some of these kind of, I wouldn't say bottlenecks, but in Docker, but nowadays it should have better support.
I think we have one question right there.
Yes.
One little question. When you were Dockerizing or Dockerizing or whatever, your internal multifunction server, did you build the Docker containers by itself, or did you try to find out suitable containers from the world? And if you did or did not, what was the result?
If I remember correctly, we found like used some pre-existing images, but we tailored them. So and then we used Docker Hub to private where you can store your images privately. so to store those, because those are of course not well something if they're internal services which are only for proprietary for us, we don't actually need to share them because there isn't that much with
But there are many general purpose containers for general purpose needs available.
Yes. And for example, we deploy like common services such as Jira and then there are some Jenkins and these kind of things. So there we of course utilize the available core containers or the images, and but then there were of course some configurations. If we needed something, then we did the configurations and then stored them to the private registry at Docker Hub and utilized those. But yeah, of course, there is quite a lot of those pre-made, but there of course you need to be careful about the security and so check that they are from a trusted source, and even do some internal checking, even if they are from trusted source.
Any more questions or?
Probably I need something, but did you mention that you have private text behind of your firewall or internet setup or web? Where is your container image set?
Oh, we use the Docker Hub, the software as a service.
Yeah.
So we store it there in this private plan.
Yeah, so it's on the cloud.
Yeah.
Private cloud.
Yeah.
Okay.
All right.
Thank you so much for Ilmari Kontulainen. So, ladies and gentlemen,